Okay, so welcome back. Today I'm going to talk about OpenFlow channel, which is the continuous episode of the last previous videos. So in this case, we're having a trapezoidal channel because previous one we already had the prismatic channel with like the semicircle, and we have another prismatic channel with like a triangle. So today we're talking about something like trapezoidal, and it is also related to the assignment that we have last week as well. Okay, so this is the question. A trapezoidal channel with a geometry shown. So there's another picture I will draw later. So it carries a flow of 25 cubic meter per second down a slope of 0.003. So find the normal and critical depth relative to the horizontal bed of the channel. So the horizontal bed of the channel, there, like for example, this is the channel. So this is the horizontal depth, horizontal bed of the channel that they're trying to point to. So we're having the Chesi coefficient. Okay, so now let's draw the figure together. So I assume this is actually 30 degrees would be somewhere down here. It's like a really tiny angle. So this will be the reference point, and this is 30 degrees for the angle. And for the length here, it's 2.5 meters. So that's all for the figure. And they're trying to ask for the normal depth and the critical depth. So basically, for the Tracy equation, we have learned in the class already. So let's talk about the general parts of this thing here. We have the area. We need to find the area first. So I will copy this to the other page, the squared one. If you guys have watched my previous video, I'm switching to uh, graphed paper because I cannot write on blank paper. Okay, so now we're trying to find the normal depth here. And for this normal depth here, we need to find the wetted area and the wetted perimeter. I mean the flow area, flow cross-sectional area. So for A, it equals to 1 over 2. I will say that B plus B, and then replace with 2 times of h square root 3, and everything here equals to h. So basically, for the normal thing, there's the bigger and the lower, right? So the bigger part here, we plus the base together, plus the top base and the bottom base, and then we multiply by the height. Like this would be, if okay, so if the water is around here, the height would be this one. This is the height. Okay, so if we simplify it together, we will have HB here 1 over 2 2b plus 2h square root of 3 times h, and this would be 1 over 2, okay, 1 over 2, 2 here will be factored out, and it would be b plus h square root of 3, and this one will be gone. So here equals to h. And then we have hb Okay, so we basically kind of factor something out like this, and we have square root of 3 times h over b. So it's like we're trying to factor b out of this thing. Or you can actually write hb plus h square root of 3. That is also fine. Okay, so now we can find the wetted parameter. So for the wetted parameter, it's wetted parameter. The symbol is p. Wetted parameter. The symbol is p. B equals to b plus 2 times 2h, and the answer is b 1 plus 4h. It's similar to the previous one because we're trying to like factor b out of this things here. So if you multiply this one, you get this one, right? And if you multiply this one in, it will cancel out, and we will get this one the same. It works the same for this one. If we multiply the whole thing here, we will get this one. And if we multiply this one into this one, so it's basically this one to this one, and b cancel with b out. So yeah, it depends on people's preference and taste, like whether you like to factor out which way. Because in this case, we're having this one the same HB here, so we can, like work on the RH, the hydraulic radius, later. Okay, so for if there's like a question, where is this from? Okay, so B here is the base. Okay, so I'll draw for example, here's the water, and the base is from here to here. So this is the base, that is 2.5 meter, or I say it's the B. So according to the trigonometry, or we say that geometry, yeah. So we have done it in the previous video, that we're talking how to find the formula of, like, the trapezoidal is different from the normal triangle, right? So there's something around here this is the similar triangle with this one. So these two triangle plays the same role, and if this one is 30 degrees, this one's supposed to be 30 degrees as well, so we know h, right? So for this one, we're going to find this part here and this part here. So that's the reason that b here is actually b plus 2 of h square root of 3. So this part here is h. This part here is h square root of 3. This part here is also h square root of 3. So h is here, right? So h is here. So this part is not, this is 90 degrees, and this is the hypotenuse. So will be the tangent of 30 degrees, and it is square root of 3. And it works the same for this one because we're trying to find here, right? So yeah, it's 2h because we're finding this one, and then we plus with this one, plus this one, and then we plus this one, which is the wetted parameter. In this case, it's quite easier if they give us the degree, because in some parts they're going to give us a slope or something that's quite, headache. So yeah, it's good that this problem is giving us the degrees of slope instead. I mean the angle of slope instead. So next thing we're going to find is the hydraulic radius. Okay, so for the hydraulic radius, we're going to find the RH, right? So RH equals to A over P, in which A is the flow cross-sectional area, and P is the, what is the P? Wetted parameter, right? So for A over P equals to this one that we found, and this one. So it's H. I think I need something higher here. Okay, so HB 1 plus square root of 3h over b, and over everything here it's b 1 plus 4h over b. Okay, seems like we can cancel something out right here. This here, ouch, b here and b here. Yep, we can cancel that out because it's multiplication. And after that we have only h, right? So for the normal flow, okay, so I'm going to write for another here part here. It's h b plus square root of 3h over b plus 4h. Does that make sense to you? Because as you can see here, it's I multiply this one so it becomes b, right? Okay, I multiply this one, it becomes b, and this is like this. So the overall factor is b, and overall fraction is also b, so we can cancel b out here because for example 1 over b over 1 over b equals to 1 over b times b over 1, right? So we can cancel this one, this and that. Okay, so then we can move on to the normal flow. So in normal flow, we can use q equals to au, and for the Chazy equation, the Chazy coefficient, oh no, not the Chazy coefficient, yep, and square root of RH as and times a, which is a is not inside the square root. So hence, q is equals to Chazy coefficient. So this is finally the Chazy coefficient that we're going to use. Chazy coefficient, which is inside the square root, or I would write like this so that you guys can see it easier. Square root of Chazy times h. Wait a second. I think something is missing right now. Times square root of s. So square root and square root can stay the same here. Times slope, which is a slope. And then we can write the RH. RH, 1, it's not 1, right? It's b plus square root of 3h and b plus 4h. And after that, we can multiply everything with okay, sorry, so I did something wrong. I think something here is supposed to be like this way. C S H. C is the constant, slope, and this is the RH. And then we times with the A, which is HB 1 plus 3, square root of 3H over B. Okay, so this one will be inside the bracket. Okay, and finally everything here, we're trying to solve it as easy as possible because we don't want to, it's quite complicated. Yeah, it's quite complicated right now. Um, so we're trying to find age, right? So when the length are measured in meters, so here we have let's say this is still Q here, and we have the base here, and the base here is from this one, because it's a multiplication, so we can arrange it every one. Okay, I made another mistake, I'm sorry. So this part here is only here, okay, times constant times CB like this. Okay, so then we can see that the C can also move to this part and our square root of S, and everything is like this. And after that we can find this one H here is inside, it's 1 over 2, right? And this one is total 1, so 1 plus 1 over 2 equals to H to the power of 3 over 2 times with everything that's out here. It's, oh my god, it's 1 plus wait a second. I made a really huge wrong move here. Okay, B plus square root of 3h, or B plus 4h over here 1 over 2, right? So we times with, this is times with 1 plus square root of 3h over b. Okay, so now we have Q here. So we're trying to find H, right? So finding H is a little bit very tricky. It's getting tricky and trickier because there are like unknown numbers. So we're trying to find from H here to here, H here to here. So for the reverse, it's going to be 2 over 3. Okay, so Q, okay, this part here will come here. Q, B, C, square root of S, everything here will become square root of 2 over 3. And then you times with everything that's going to happen here. Everything that's going to happen. Yeah, of course, it's going to happen. A really, really eye-opening ceremony over B here. And then we are going to find 1 plus square root of 3 h over b, and for the top part here it's going to be 1 over 3, right everyone, it's going to be 1 over 3, and the down part here there's no power at all. So we know the base, right? So we can substitute the base inside this one, and then the only thing that is going to happen left is h. So now we have q. We also know q. Okay, so from the question here, the q that they're having for us is 25. Okay, it's equals to 25. B is 2.5 times C is, I can't remember. C is 45. Wait, do I need to put the right? Okay, I already wrote it down and I'm asking. Yeah, we need to put the units inside this one because there's a lot of units that are unfamiliar with. Times with and we have times with the s here. Square root of s is 0.003. Okay, and this is the q here, and everything here is equal to, can anybody give me the answer? It's equal to, wait a second, 25 over 2.5 times 45 times square root of 0.003. And then we don't forget to power it. Okay, so, oh wait, it's up here, power to the 2 over 3, it's 20, no, not 20, 2.54. So the answer is 2. This is not the answer, guys. 2.43. Oh yeah, wait, 438 is 4, right? So this is not the answer yet. We also have this part here. Don't forget. This part here, it's times with 1 plus, okay, I will not write it here. I will write it here to save space. 1 plus 4h, but h we're finding, but 2.5 is the base, we know it. 1 plus square root of 3h times over 2.5 meter, and upper part is going to have the power of 1 over 3, whereas the downer part here does not has any. Four over 2.5 is 1.6. So this one is 1 plus 1.6 h. This is over 1 over 3, and the down part here, is it called the denominator and something, right? The factor and the denominator, not sure. Square root of 3 over 2.5 is 0.6928h. Okay, so then we can find using the solver in the calculator. So let me try it. So solver and the calculator is still the same. We also use the same method and the same stuff here. 2.544 times with our part is 1 plus 1.6 alpha x, everything here square root to the 1 over 3, and here it's going to be another bracket down here, and down there there's no bracket. 1 plus 0.6928 overall part, and we click solve. So I will click solve again. It takes quite seconds until it releases. Yay, we're finally done with this one. I'm so happy. We're getting faster and faster in solving exercises. Okay, so x here we have 1.74. It 1.784 minutes. Okay, and then we need to find the critical depth here. So for critical depth here, the fruit number. So every time we need to find critical depth, we're always finding the fruit number equals to u over square root of gh. GH. Okay, and then velocity here is u, and mean that here is h bar. U equals to q over a. H bar here is equals to a over bs. Okay, and then a here is the same, and q is already given 25 cubic meter per second, and bs here is 2 plus 2 square root. Do I need to write this one? B plus 2 square root 3 h. A here is hb 1 plus square root of 3 h minus b. Okay, so now everything is done here, and we're going to compute the proof number next. So for critical depth, of course, critical depth is fluid number equals to 1. Can you guys remember, if it's subcritical, it's going to be more than 1, right? And supercritical is less than 1. The two of them is going to be, one is going to be larger and another one is going to be less than 1. Yeah, so you need to remember that, but I haven't memorized it yet. So okay, then we can find the root number, which is this case I'm going to square root it, and we get u square over gh. So u square is q square over a square times with g a over bs, right? Because this one here is like over bs, so I'm moving here, and this is like over a, and then I'm moving here. Yeah, moving back and forth, back and forth. Okay, so then we can find we obtain. Okay, why I'm trying to use smart words. Okay, and then we what do we say that in English? Let fr squared equals to 1. And then we get q squared times b plus 2 square root of 3 h over g h to the power of 3, and b cubed. Cube and power of 3 is just the same. I don't know why did I use two expressions for one meaning. And then we get to the power of 3 here. Okay, and then we actually need to find the h3, right? So h3 here will nominate up here. What do we say that nominate? Is leveled up, is upgraded up here. So h to the power of 3 here is equal to q squared b plus 2 square root of 3h over g b square root of 3, 1 plus 2 over b 3 here. Okay, and after that we're trying to find h, whereas h will turn into square root of 1 over, not square root, power 1 over 3, because, yeah, you guys know the reason. Because that's the reason. Q 2 G B square. Wait, I lost one B. I lost one B, help me. Wait, this is always square. No, I did not lose it. There's supposed to be 3 here. And then this one is going to be 1 over 3. And then we times with 1 plus 2 over 3 h over b. So the upper part here is going to be the power of 1 over 3 here, the same. But the lower part, there's no power because it's already 3, so มันตัดกันไปแล้ว 3 times 1 over 3, so yeah, it's already ตัด h over b. So here we're going to find the length. We're going to substitute the same. So g is 25 square over 9.81 times with 2.5 cube. And this is going to be 1 over 3 times with 1. What is 2 over 3, guys? Help me. 2 square root of 3 divided by 2.5. The answer is 1.386. And we're going to plus this one as well. Square root of 3. I think it's the same as the previous one that we've done earlier. Times 2.5. No, 2.5. I just clicked 25. So the answer is 0.69. 0.69 H. Nice. Very nice. I'm depending too much on the flexibility of, not flexibility, accessibility of BitNote, so I'm not trying to draw a straight triangle anymore. Okay, the function, the option of, not the function yet. So then we can use the solver to find the h, which is equals to, give me some seconds. I'm trying to discover in the solver. Okay, tick tock, tick tock, tick tock, tick tock. Okay, so now we have 8c critical depth is equal to 1.536 meter high. So the answer is Hn equals to 1.7, is it 1.784 meter, and Hc critical depth is equals to 1.536 meter. This is the end of this exercise. Okay. I actually got a heads up from the professor that, not a heads up, what do we call that? The hint for doing this exercise, the kind of square exercise. This is wrong. Don't try to look at it. This is wrong because I cannot find this theta. But he said that in case of y equals to y, y equals to r minus r cos theta. So we're trying to find theta by trying to input cos minus y minus r over r, something like this, but I haven't done it yet, so okay, I'm going to give you the answer later. Yeah, I guess so. We need to do that. We need to insert everything in that part. Because in this case, I'm trying to find this one. So this one will substitute as cos minus y minus r over r, like this. But we're trying to find y. We're not trying to find theta, right? Yeah, I'll check that later. But yeah, I will give you as a gift next video. I don't know how many times I've been using the word next video as a method to lure people, but still, yeah. I got no views yet, but I know you guys will come to see these videos before the exam, right? So I'm just leaving the heritage to you guys. Okay, now I'm trying to read this question. Sorry I didn't have like any preparation because I'm not so well these days. I'm being serious. Not really that well, but I'm well, so don't worry guys. Is it this one? A river consists of rectangular channel. Why am I trying to read now? A river consists of rectangular channel of the width 5 meters. So we're going to use that 5 meters as the important value. Then at one point it appears of a simple beam. Can you remember what beam is? I don't remember. Cause a local narrowing with 3 meter. Wow, that's from 5 to 3. Wow, impressive. Okay, so then we're going to find what are they trying to ask? You mean like, do you see the question is too hot, too much, so you don't want to read anymore? Do you guys see the same thing as me? Okay, so now we're trying to find the bottom. Oh, not to find the bottom of the bridge deck is 1.7 above the bed of the river. So it's like the river is like this, and the bridge. Sorry, the bridge. Don't get me wrong. I mean the bridge. The bridge back. The bridge deck. The bridge deck is 1.7 meters above the bed of the river. Question A. When the river flows, I think that's the title of K-drama, is 11 cubic meter per second, the constriction of the channel by the bridge causes a subcritical to supercritical through number. Sun transition. Calculate the depth of the water upstream and downstream and enter the center of the bridge, stating any consumptions made. So at the flow rate above a hydraulic jump, I think we learned this week. Right, this week, right, yeah. Nice that I'm trying to do this week. I almost tried to do this last week, okay, so nice timing. And where was I? A short distance downstream, so try to find the depth of the flow immediately downstream of the hydraulic jump. And C, show that the river flow is 22 cubic meter per second, then the flow passage beneath the breath will be completely choked. A new word for me, choked. Okay, so then we need to assume something first. So the constant to consume the constant total head, constricted section long. The constricted section is long enough to establish the parallel flow of the critical depth, and the downstream control so do not prevent any supercritical flow being established. And this is what we need to assume. Okay, so first of all, I need to add a page here. So, has it been 14 minutes already? And this is going to be a long $8 thingy. Okay, we need to find the total head from the critical conditions. So at the narrow point to critical depth, we need to find the critical depth here. My handwriting these days are not that well. Critical depth here is HC equals to QM do I write QM this way so that you guys QM square over G. Okay, so this is my Q and this is my G. So don't get the two wrong, okay? Okay, all my fan clubs. Why am I talking this way? It's so weird. Yeah, someone is awake from, being on bed for so many days. Okay, so HC Q equals to 11 over 3 times, oh no, not times, it's just square. And this one is 9.81. Everyone knows what this? Okay, so this is my G. This is my Q. And this is my 9, okay? In case you see something in the in the next video that you're going to confuse which one is Q, which one is 9, or you have to need to recheck with my handwriting again. Yes, and then for the flat bed, the total head relative to the bed is corresponding to this critical specific energy. So we have the specific energy here on, this is not the specific energy, okay? So this is like the total head. But this total head is for flatbed. You understand what it means, right? The flatbed is it's like the river. What is this sound? Excuse me. Something is chuckling. So CE equals to, CE, where's that from? EC is equals to 3 over 2. HC and HC that we found earlier. So this is HC. HC that we found HC. IC. It did not square. Times 1.111 equals to 1.667 meter. So basically, the flow transition is stated to occur. This must be the total head. So it's like we're trying to find the total head, but we're trying to we found the bits of the total head, not Bitcoin. Total head is equal to H CS plus U square plus 2G. Okay, so Z square is equal to H plus Q over A, you can remember, right? But then we need to do this one. As for the river, I think it's the rectangle part. It's not going to be a trapezoidal river. That would be quite funny. There is actually, of course, because the river, if you look carefully, this is the Jrang. What is Jrang in English? Jrang, the riverside, no, not the riverside, the riverbed. The shore, right? The shore. No, not the shore. Shore is up like this. Okay, you can imagine, right? So this is where the people walk, right? And this is the Jrang here, and then we get the bed, and then this one. So basically, everywhere is gonna composition of, trapezoidal. Sorry. Okay, so now we have 细数数学生肖 1.667 equals to H plus 0.2467 over H squared. Okay, So in this case, the upstream rearranged an iterative formula for the subcritical. We're trying to find h here, right? So h here equals to, just rearrange the formula without any headache. 2, 4, 6, 7, 8 square. 40 minutes have passed and we have not finished this one yet. Yeah, we finished the previous exercise and we're already inside this one. Okay, so then we're trying to find the h, whereas we can do it quickly. Let me grab my calculator. Alpha x equals to, alpha x equal to alpha equal 1.667 minus 0.2467 over x. Shift solve. Wait for 3 seconds. It's here. 1.5666 meter. So this is the h here, and then we need to rearrange again for the supercritical solution. So this is the subcritical, and now we'll find the supercritical. H is equal to square root of 2467 1.667 minus h. These are the formulas. You can just memorize it or understand the formula. As for me, I'm going to memorize the formula. Yeah, there's like case that we're going to calculate when it's going to be supercritical and when it's going to be subcritical, right? So now we get, yeah, we're doing this one again. We're trying to use our calculator to it max to the maximum use. It's expensive. Why not we use it to its maximum use? 0.2467. What am I talking? I'm just talking gibberish. 1.667 minus alpha x, and the answer is 1, 2, 3, 4, 5, 6, 7, 8. It's not showing the answer. Okay. 0.430. Oh no, 4503 meter, and then the depth upstream is, okay, so then we can answer for A. Depth upstream is 1.57 meter. 7 is like this. And under the bridge equals to 1.11 meter, and downstream, you know what upstream is here, downstream is here. This is the definition of upstream and downstream. 45 meter. And then we can continue to B. Do you guys want to take a break? B. I'm so tired already. B is equals to condition of upstream of the hydraulic jump. So we have H equals to 0.4503 m. So then we can get the I'm trying to say V again. The velocity, we just say U. So V is for velocity. But U stands for velocity. Oh, so cute. Oh, BH equals to 11 times, no, not times, up down here, 5 times 0.4503. Answer is so basically 0.4, the 5 is the width, and the width is the base. Because, of course, if a river is this way, this is, oh wait, this is the h, this is the base, even though if it's in this, what I'm trying to draw. You imagine like this, right? The river is like this. So this would be the width, length, length, height, right? Yeah. Okay. So don't go any farther. This is the v here. Meter per second, and then we can find the FR. What is the FR again? FR is the fluid number. So FR equals to U over, okay, I've been saying the U over G square root of GH multiple times, and I feel like I don't want to see it anymore. 4.886 times 9. We all know this one, so don't ask me where it's from. And you can ask me where I'm from. Sorry for the notification. I forgot to turn off my phone notification today. I did not turn it off on purpose because I'm not going to miss out any important information anymore. So hence this hydraulic jump h for the downstream. So this is the h here equals to 0.4503 over 2 minus 1 plus square root of 1 plus 8 times 2.325. 2.325. Oh, it's here. Square. Okay, I need to use a calculator. Answer is 5. Oh, no, not 5. I forgot this is multiplication. Yep, 1.27. Okay, so this is 1.27, and then the answer that downstream then we are going to find the C, which is the last one. Yay! Again, to finish early today. If the discharge increases to 22 cubic meter per second, so the critical depth of the narrow point is AC equals to QM square for G. Look at my G. G. Okay. This is 1 over 3 equals to 22 over 3 over everything here on 9.81. 22 is from the 22 that we not assume. The question asks us to change it, and 3 is from the width. So answer is 1.763 meters. So it's clearly sees that the bridge deck is 1.7 meters, right? So the critical condition cannot be attained. So the flow must be choked, of course. You can see up here. Where is it? Where is it? Here, 1.7 here. So that's the reason that you need to highlight every numbers. Numbers. Okay. So 1 point. This. This is even easier than this one, right? Right? Easier than the previous one. Of course, it's easier because it's shorter. So h here is h equals hc equals to 1.763 meter exceeds 1.7 meter, and it shows that the flow must be choked. Alternatively, you could rearrange to find the flow rate that corresponds to critical depth of exactly 1.7 and show that it is less than 22. So can you remember during the past few days that we already done like the two methods, right? So method number 1, we're trying to find if it exceeds 1.5. Oh, no. They give us a Q, right? So Q is over 1. It means that the flow pipe is not. What did the teacher say? uh, efficient. No, sufficient enough. So we either find the Q or the YN. So in this part, it's either find the HC or the Q, and of course, we rearrange. We put HC here. Okay. I'll just do it. I'll do it in pink. So 1.3 here. I'm going to substitute 1.7 meter inside this one, and we're going to put Q over 3 here over 1.3, 9.81. So Q equals to silver. Q equals to silver. Silver is my favorite bay now. I don't need to try to rearrange the formula anymore because it's doing it for me. Why it didn't find it, not find it. What do we say that? Figure it out. Figure it out when I was in high school. So yeah, we cannot use calculator in an exam, but I wish I have learned it before. But I did not own this calculator before I came to the university, so it does not make any sense. Oh, my calculator is also... Just kidding. The equation is too hard. I think I made a mistake. um... Is it 1 over 3? Oh, see, I forgot again. It's supposed to be 2 over 3, right? Right. 2 over 3. Yeah, because this one here is going to times here. I'm not sure if my calculation is right, but I get this number 314. So I'm going to substitute this one. So wait a second. I'm going to substitute this one, and I'll see if the answer is right. 1.7. Yeah, it's right. Wait, why is it minus? I want to know the reason. Minus 2 4.314 over 3 power 2 over 3. Down here is 9.81. Oh, it's really 1.6, 1.67, no, 69. Okay, so this is less than 22. It's obviously less than 22. So it's going to be choked. Yeah. Okay. So now we have 5 more minutes. Let's review what we have learned today. We have learned a lot so far. I'm so impressed. Okay, so now I'll just give a glimpse of the review. So here's the prismatic channel. So I have done the example, 3 examples so far regarding the types of channel. So I have this type of prismatic channel with, what do we say? What is this called? Triangle, three face, 3 sides is triangle, right? So I have a triangle. I have this is the, yeah, so preliminary calculation, and then we can find the critical depth. I can't go for 2 hours because my voice is going to break soon. And the prismatic channel for the cross section, okay, so this is another prismatic channel with this. Then we have, okay, so here we have 2 methods. So in this case, there's always 2 methods, right? So try to figure out which is the best way to calculate for the answer, because the answer is always the same. Answer is always the same. So this is the trapezoidal that we have learned today. The owl here is so nice. Ah! Okay. Here. And then we have the last one, which is the river consists of. This is the kind of river. So I want to explain this dot again. Example, there's the river like this, right? The river is flowing, the water is flowing. So there's a bridge. Okay, can you imagine this bridge? This is people. Should I draw it in this one? Going to use a different color for the bridge. And different color for this one. This is the people. Or the car. It looks like an octopus. Okay, just imagine. So the river is rectangular channel. They already say the rectangular channel because in some cases there are trapezoidal river, right? But this case we're only considering for the rectangular channel with the width of, so the width of the river here. Can I imagine the width of the river here is 5, but there's the one of the parts like where the people walk. So the beam bridge cause a local narrowing to like, so it kind of like this, so it's becoming like this, so it's only 3 meter, and the bottom of the bridge deck is about 1.7. Actually the bridge is like this, right? But I drew it like this because it looks cute. When the river is flowing 11, so this is flowing at 11. So suddenly they switch it to 222. Not they switch it, like if the river flows at this one, will the bridge be completely choked? It means like the bridge will be collapsed. Like water is going so fast. Will the bridge be collapsed down here? Okay, so I guess this is all that we have to know about this one. We need to just like imagine if the water is like this, and what if the length is shorter? It narrows down the length or the width of the bridge. What are we going to do? So what are we going to, when we construct the bridge, what are we going to do with the bridge here? Okay, so that is all for today. My voice is gradually fading. So see you next time.